Good morning, everyone. This is John Pendleton, your trainer today, and it's about 8 a.m. So we will go ahead and get started on the variable speed water to water. Just as a pre-warning, excuse me, this is a longer webinar, so we will take a break about halfway through, a little 5-minute break. So we'll go ahead and we will get started. So I just wanted to show you the, let me go back here. This is our technical support department. I just want to let you know that we always have, help available for you as far as technical support, design services, customer service. So we do have 5 guys back in technical support. And these are the 5 guys. I'm the little middle guy there. I don't answer the phones a whole lot unless we're super busy. I normally am handling the trainings now. So we've got that new equipment that came out yesterday. So I've been working a lot on the training on that Advantage unit. So you can email us if you have pictures of, an install you want us to look at or something like that, a startup sheet or something, and you need to email that in. You can email it over to the technical services at Enertech Geo, and then you can give us a call and we can go through the information that you sent. We do have an after hours phone, and it's just that, after hours. So anytime after 5:30 p.m. or before 7:30 a.m. and that's Central Time, you can call us on the 618-267-1768 number, and one of the guys will take your call. Now, we're not in the office, so we may not have all the information that you need, but we'll certainly get as much as we possibly can for you. We do have design services available for you as well. And we have Jeremy and Angelique, and they can help you with some equipment and loop, pump sizing, geoanalyst. If you got an older piece of equipment, and I don't care if it's a Climate Master or Bosch or even an Enertech unit, we can match those up to a newer unit. And we also do a lot of solar design. That's what a lot of their time is spent on. But if you need some design help, you got some questions on design, give us a call. We can definitely give you some assistance there. So this is our Dealer Secure website. I'm sure you may have already been aware of this, but we would recommend that you go ahead and register for this site. We'll send you information, if we have any tech bulletins or something like that, we'll send you the information. We'll send you a monthly little newsletter, but we're not going to sell your email or anything like that. But I'd recommend that you that every user go in here and fill that out. You can get into our secure site and access the training. If you see on this page here in the upper right hand corner, you've got the Enertech University link, and that'll take you to all of our training. So we've got quite a bit of information here. This is the Enertech University site. If you follow that link, it'll take you over to this page, and it'll show our curriculum, our online video library, which all these webinars that we do are now recorded and they're uploaded to our YouTube channel. So you can check out our YouTube channel, which is Enertech University, and you can see any past webinars that we've done and definitely watch those. There's no charge for that. So we'll go ahead and dive into the variable speed water to water unit. We'll call it the WV unit. W stands for water to water, V stands for variable speed. So basically this unit will do heating, cooling, and up to 100% of your domestic needs. Now I say up to, the TurboMax tank is able to handle a standard hot water flow, through a shower head or maybe a washing machine. But if you've got a shower with 7 shower heads in it or something like that, then we may not be able to supply 100% of your domestic needs. So we'll talk a little bit about some of the setups here in just a little bit, and we'll talk about that a little bit further. Again, it is a variable speed compressor, and it ranges, we have two units available, the 040 and the 060, so about a 3.5 ton and a 5 ton unit. So the unit, the 040 will go from about 1.5 tons up to 3.5 tons. And then the variable speed 060 will range anywhere from 2 to 5 tons. And those are based on the RPMs. So it'll ramp that compressor down to about 1650 at the lowest, and usually about 6500, but it can go up to about 7000 RPMs on the high end. We have higher output load temperatures, so we can get up to about 135 degrees. So that works well when we're doing our domestic hot water. We've got plenty of range there for the domestic hot water, as well as doing some forced air heating and cooling with hydronic air coils. There's an internal variable speed load pump, and basically it will maintain your delta T. And then the unit will control, based off of a control wiring, the external variable speed flow center. There is an internal electric immersion heater. It's a 9 kilowatt heater, and it's used for supplemental or backup. If for some reason the geothermal unit went down, we would have the backup heat. It does come with an outdoor temperature sensor that we will use for outdoor reset, and we'll talk about the outdoor reset a little bit later on. And we have on-demand controls with multiple set points. What that means is we have a control that can handle a radiant call versus a hot water call versus a forced air heating call. So all three of those calls could have different set points as far as water temperature. So we were able to handle all those multiple set points. We base all of our AHRI readings off of a heating capacity of 32 degree entering source and 104 degree entering load. And in cooling, it's at 77 source temperature and roughly about 53.5 entering load. We normally design our floor temperatures for around 85 to 95 degrees. So this variable speed will work well for that. These are some of the efficiencies. You can see on the bottom here, we've got the WT, which is a single stage. We've got it in the 048 and the 060. And we're just comparing the two-stage unit with the variable speed on the top here. So, you know, when we're going to be running in our part capacities, we're going to be running about a 3.9 COP at times. So the lowest we're probably really going to see in heating is about a 3. So we're definitely more efficient than our two-stage water-to-water unit, and we've got good capacities as well. Here's just showing some of the different efficiencies at the RPMs. So you can see it's 6,000 RPMs, which is about full load. We're running about a 3, but when we're running in these part loads, you know, 2,600 RPMs, you know, we're at a 3.9, 3,300 RPMs, we're at, you know, 3.8. So we really have good efficiency numbers. And when we're going to see the variable speed run at lower RPMs, you know, it's not going to sit there and run at 6,000 RPMs all day long. So that's when we're really going to get our savings on this unit. And just some cooling EER numbers as well. These are all listed in the IOM. So definitely download the IOM if you've got some questions and take a look at it. We've got a lot of this information in there. So if you want to dig in a little bit deeper, just check out the IOM. And you can access that IOM if you're GeoComfort, Hydron Module, or TechCo, depending on the brand that you normally sell. You can go to our websites for any of those, geocomfort.com, hydronmodule.com, and techco.com. And you can download the manuals there. And you can also go to our secure site and get into the literature there. It's usually easier to find it on the branded websites. Got some nice pictures for you to click on, and it'll ask you if it's residential, commercial, and then it'll show pictures of the product, and you can pull up the IOMs. Now, I wanted to show this little chart here. You know, let's say this WVO40, it's a 3.5 ton unit, but as temperatures, entering source temperatures go down, obviously we're going to lose capacity. So you've got to take that into consideration. The most that this VO40 can do is 3.5 tons. So make sure we're not trying to overload the unit with too much load on it. With that said, you know, if we have a 5 ton unit, you know, you don't want to put 5 tons of radiant in the floor and then have a 5 ton air handler for doing heating as well. The unit will never shut off. It'll always be switching back and forth. It'll be hard on the unit. So it's a 5 ton unit, so it can only do 5 tons. You know, whether that's 5 tons of radiant, 5 tons of forced air, or 5 tons of the combined. You know, it's the total load. So we just don't want you to try to do too much with this unit. We saw that a little bit early on. Maybe we weren't real clear with what we were trying to accomplish, but we all learn from our, not necessarily mistakes, but we all learn. So, and just some, again, cooling, same thing. Obviously, capacities, they don't change quite as much in the cooling as they would in the heating. But just remember, as your source temperatures change and your loads change, so does your heat of extraction. Or excuse me, heat of rejection. And we've got it again for the 060 and cooling and heating as well. We'll talk about the controls here in just a little bit, but we use outdoor reset so we don't have to have as high of temperatures, and we can get the unit to run more efficiently. This is with the domestic hot water option, we have to use a certain tank. That tank is called a TurboMax tank, and it's built for for heat pumps. So basically what we have is we've got a coil inside of a tank. So the domestic hot water for your home runs through a copper coil that's inside the tank. The WV supplies bulk load water to the outside of that coil inside of that tank jacket and heats that water for the domestic. So we have 2 tanks available, the 45 and the 65 gallon tank. And here's just a little comparison. If you've got if you've got electric or a gas water heater and you need to put in a TurboMax tank. So it'll give you kind of an idea of if you had what size electric water heater you had, what size TurboMax would work for you. So again, we have to use the TurboMax tank. There is no other tank that we can supply or that you can access that will work with our domestic hot water. So you've got to choose between a 45 and a 65. I think that there might be available a 100-gallon tank. If for some reason maybe you had a commercial application that you're trying to use the WV in. So you might want to check into that if you've got that application, but I can't promise you that it's available because I don't really remember if it's still available or not. But I think that it is, but don't hold me to it at least. Let's just say that. So the recommended applications for the WV unit is a high mass radiant floor application. So We've got good flow through there. The main thing on the WV unit that's so important is it's got to see minimum flow. So it's got to see at least, I think it's a little bit under 5 GPM. So if any zone can't handle 5 GPM, there's things we've got to do. So obviously, if every zone can handle 5 GPM and satisfy their heating load, then that would be the best way to go. So that would be a high mass radiant floor application. Hydronic forced air. You can use that with zoning on the air handler. You can put a hydronic A coil above a gas furnace and use it on the dual fuel application. So we can do heating only with the forced air. We can do heating and cooling with the forced air. Again, optional 100%, up to 100% of your domestic water heating. And as time goes along, we will be adding some connected controls and upgrades to the equipment. So as we learn more and more on this equipment, things have changed. Some of the piping's already changed. Some of the wiring has changed. Some of the controls we use have changed. So when we find bigger and better things to control this or to use, we definitely upgrade the controls and things. So we do have a WV selection chart. So if you go to enertechusa.com/WV/selection, that will take you to this page here. And basically in this, you're going to pick your brand, the size of unit that you would like, whether it's residential, commercial. The voltage won't change whether it's residential, commercial, just the warranty on it. It'll ask you if you're going to do hot water configuration. That's a yes or no. And then the type of flow center. We have a non-pressurized single pump variable speed flow center, and we have a pressurized flow center, variable speed. To me, it doesn't matter if it's non-pressurized or pressurized. That's usually a preference. I've used a lot more pressurized, so I prefer pressurized. A lot of people prefer the non-pressurized due to air and that kind of thing. To me, it doesn't matter. It's not going to affect the unit, but just choose which one you want. You're going to choose your control type, or your tank options, and then it'll get into your controls. And we'll talk about controls after our break today. So once you fill out all the information in this, it'll spit out the model number of the unit that you're going to get. And all the parts that come with it. You can then take that and give it customer service, and they can order that unit. We had a question, does pressurized or non-pressurized depend on what type or what antifreeze is used? No, it's just whether it's got pressure on the system. Pressurized versus non-pressurized. A pressurized system uses pressure in the system, in the piping, for the pumps not to cavitate. So it's got to have at least a couple pounds of pressure so the pumps don't cavitate and it'll move the flow. Non-pressurized, it'll use the standing column of water that's in that tank to basically prime those pumps. But yeah, it doesn't, either a pressurized or a non-pressurized system, if you're somewhere where that water temperature is going to get to 30 degrees, you're going to have antifreeze in it. So, maybe down in the Caribbean or down in Florida or Texas, you may not need antifreeze, but, here in Illinois, anywhere in the Midwest, up north, Canada, you're definitely going to be below that 30-degree mark. And so anytime we get below that mark, there will be antifreeze in the system. We do have some design calculators to help you out with some pipe sizing and getting some hydronic calculators for your radiant floor and fan coil pressure drops, and it's geoflow.com. You can sign up just like you do for Enertech, and then you can access a lot of their calculators. They have loop field sizing, pump sizing, quite a few calculators on their website, and they're real good about not sending you junk email. So definitely check it out. We work really closely with GeoFlow. As a matter of fact, my boss, Jeff Hammond, he came from GeoFlow. So, I'm not trying to push their product or anything like that, but I can tell you that their calculators are really nice. So I would recommend using them. On the loop field, you can use the LoopLink software to calculate the loop length. If you are using it with domestic hot water, we have a little bit longer run times when we're doing the domestic hot water. So we need to probably add a little bit of extra loop. Now you can do standard sizing of the total load, but additional loop size for the domestic hot water is necessary and is critical. So you can check out the LoopLink software. If you still have questions, definitely give me a call and we can discuss how much we think you really need to add. So a lot of times if you've got a vertical loop, they're just going to add one more well, or if you've got a horizontal loop, they're going to put in one more trench, basically, another ton of capacity or so. So this is the WV to the right. You can see a little box. The 040 and the 060 are the same size, so they're not going to come in a different size cabinet. They'll both be the same size. So it's got the Copeland scroll with the inverter technology for the variable speed. We're using 2 swept braze plates in the unit, one for load, one for source. We have an electronic expansion valve. We've got to use the electronic expansion valve as we have to throttle pretty quickly that refrigerant. So we have to use an electronic expansion valve. The one thing that is nice about the electronic expansion valves is that we don't have the problem with them sticking like we do with the thermal expansion valve. They're driven open and driven closed with the head of that expansion valve with power. So if there's any kind of stuff in the system, it's not going to get stuck there because that valve is powered open and closed, or it modulates. So we don't have to worry about them sticking. At least I have not heard of one sticking yet. I think we've had maybe 1 or 2 of the heads that go on top of it fail. But another thing that's nice about that is if the head were to fail, it's an electronic control. The head can be replaced without getting into the refrigerant circuit. So it makes it really nice. It does have an internal immersion electric heater, which is a 9 kilowatt heater. And you can turn that off. It will have a separate power supply. You can also go into the controls and turn it off that way. So if you don't want to use it or you don't want it coming on, you can shut it off. And then you can have it where it just comes on in emergency or when you turn it back on. It does have an onboard HMI. HMI stands for human machine interface, and it has the communicating controls. On that picture to the right, it's that box with a little bit of blue right in the middle of it, towards the top of the unit. That's the HMI. Again, there is an internal Grundfos load pump, factory installed, insulated inside the cabinet. It's up near the top back of the unit. Keep that in mind because if you ever have to replace that load pump, you will have to take the top off the unit. So you may want to give yourself some clearance on top of the unit. Here's a little CAD drawing of the front of the unit opened up. You can see the refrigerant components down there in the lower portion, and then the controls in the upper portion there. Some of the key components in the heat pump. So this big white box there with looks like capacitors on it, that's the EV2, that's the frequency drive for the compressor. So that's basically what tells the compressor what speeds to run and how it controls the variable speed compressor. HMI, it's down here on the lower middle of the page, and it's how you communicate with the unit. It gives you all your feedback of what's going on in the system. We have controllers. We've got over here, this is the electronic expansion valve controller here. This is a flow control here. This is a flow meter that will go back to your controller and tell the HMI what kind of flow we're moving. We got flow switches. We got flow sensors. We've got pressure switches right here, pressure transducers, thermistors. We've got quite a bit on this, so we can monitor a lot of things. We're monitoring, refrigerant temperatures, pressures, flow temperature and pressure, compressor feedback signals. So we've got quite a bit that's going on that we're monitoring. So we can usually see on the HMI what's kind of going on in the equipment. Now, all of these would be for reference. If we were diagnosing, we'd always want to confirm that your flow sensor is reading properly, that your pressure switch is working properly. So we'd always want to confirm whenever we're diagnosing with our standard diagnosing tools, but this makes it helpful with the HMI. We can quickly look and kind of see what's going on with the system. We do have a terminal strip that is removable. So if you want to jumper the unit and get it to run, you can remove the terminal strip and just jumper out the unit. We'll talk about that terminal strip here in just a few more minutes. We still are using a reversing valve from shifting from heating to cooling, and it is powered in cooling mode. This middle picture here with the little black head, that's your electronic expansion valve. And to the right is the controller for that expansion valve, the XEV controller. Again, this is your variable speed compressor. It doesn't really look a whole lot different than the two-stage scroll compressor. It looks very, very similar. The only thing different is kind of like the plug that's going to it, and we've got that white box that's controlling how it runs. This is our electric immersion heater. Again, it's a 9 kilowatt. It's got a couple unions that hook up to it, and it is insulated as well. It's got that, I don't know if you guys have seen the spray foam that we've been using on our heat exchangers, but that's what's on this as well. It's kind of like a gray spray foam. Seems to be working really nicely on our coaxes. We don't have the problems with them condensing as like we did with that foam tape insulation. So when you order that WV, when you go to that WV selection chart and you spits out the number and all that, this is the package that you're going to get. It's going to be not just the WV unit, it's going to be the whole package. So we've got obviously the WV unit here, your Turbo Max water heater, the source flow center, and also your control package. This is showing HBX. I would not recommend HBX. That's totally up to you, but we've got some other controls that seem to work a lot better and are more user-friendly than the HBX. I'm not saying the HBX won't work and doesn't do its job, but sometimes it can be a little bit difficult if you don't work with them very much. So we're trying to steer people away from using those quite as much. So moving to storage, the unit needs to stand in the upright position at all times, just like a refrigerator or something like that. There's oil in that compressor, and we need it to be there when the compressor starts up. So don't stack the WV units. Now, in storage, you can stack them too high, but if you've got two WV units in a mechanical room, don't put one right on top of the other. You can put them on racks, one above the other. But again, like I mentioned earlier, that load pump and three-way valve, they're at the back top of the unit. So you may have to get in and take the top off the unit and work on there. So we recommend a couple feet so you can get in there and work on it. Don't store the unit outside. This WV unit is meant for indoor application only. And due to the weight, make sure you're using proper hand trucks, you're saving your back, It's about 400 pounds, and it's got a lot of weight right there at the bottom, a lot of dead weight. So they're a little bit heavy. Just be careful when you're moving them around. Before you install the unit, make sure you've got the proper unit. It'd really be terrible if you hooked up a unit and you realized, well, this is a 3.5 ton unit and I need a 5 ton unit. So just make sure we shipped you the right unit. Inspect all the electrical connections, even the factory installed connections. Sometimes a lot of terminal blocks sometimes they can become loose during shipment, kind of rattle loose. So just make sure that those connections are tight and you've got good contact. Just take a quick look at the refrigerant piping. Make sure the compressor is not falling over to the side or something like that. They haven't dropped the unit. Grab the manual out of it. I'm not saying you got to read every single word, but definitely scan through it. It'll make your install go so much better if you take the time to look at some of the control setup and the components. It'll just make your install go so much better. Once you get done with the install, there is a startup sheet that we'd like for you to fill out. It basically will set a benchmark of where that equipment started when you installed it. That way, you can keep it with the unit. You can send us a copy if you'd like, or you can keep one in your job folder. But if you leave it with the unit, if you have a technician that comes out there later on and try and diagnose it, and they're, maybe they just don't know a whole lot on geothermal, or they're new to the industry, that startup sheet kind of gives them a starting point of how the unit ran when it was first installed. So they can kind of look back and kind of compare numbers and see, it might point something out that's going wrong with the equipment. So definitely always fill out the startup sheet, and not that Enertech necessarily needs it, but if you want to send it to us, we'll take a look at it and we'll file it away. But definitely keep it with the unit. Keep the IOM with the unit as well. Now, speaking of the IOM, I would not give that, to the homeowner. The reason I wouldn't, it's going to, basically the IOM is the install operating manual. So there's things in there that you're supposed to do when you install a unit. Well, I have a service technician background. I was in the field for about 20 years. So I know how things are in the field. I know that there's times when the factory recommends it be installed a certain way and it's not possible. So you kind of have to, I hate to say it, but you're kind of cutting a corner. In a perfect world, yes, you would do it that way, but this is not a perfect world. So sometimes you can't do it the way the manual says. If you don't do it the way the manual says and the homeowner gets a hold of that manual, then they're going to try to hold you to that. It's best if they don't really see how it's installed. We have a homeowner manual that they can have, and that should keep them content. It's always terrible when they get a hold of that IOM, especially, and I hope I don't have any on the phone on the training today, but engineers seem like they're the worst. They know how everything works. So I remember as a service technician, I'd always hate it when I walk into a home and the first thing they say to you is, well, I'm an engineer. It's like, oh, great, here we go. But so if you're an engineer, I apologize. I didn't really mean to offend you. My boss is an engineer as well. So I hope I didn't offend anyone. So basically what comes with the unit when you order it. This is a nice little chart we've added to the IOM that'll kind of tell you what's included and kind of what's not. I'm not really going to go through it all, but we will have certain parts that will go with it. Let's say, for example, the bypass valve is included. There's some other pressure gauges, ball valves, things like that you might want to add, but a lot of these parts are included in the unit, and it'll tell you on the notes some of the different things. I'm not going to get real involved in it, but this is in the manual, so you can kind of see what you'll get. When you go to that selection chart, it'll also tell you the parts that you're going to get. And then it will list some of the things that it recommends that you need as well in a separate list. So it makes it kind of nice for you. Obviously, there's high voltage on the unit. You guys work with it every day, but we've got to mention that it's there. So there could be numerous power sources, one for your electric immersion heater and one for the geothermal heat pump itself. So make sure that before you go sticking your hands in that box, that you know what power is there and what power is on and what power is off. We'll go over a little bit of the nomenclature on the unit. The first digit, the number one digit there, is the brand. So if you've got GeoComfort as a G, Hydro Modules an H, and TechCo is a T. So it'll kind of vary there. I do want to say that no matter what brand it is, the quality of the product does not change. The exact same components are in every brand. You know, we don't make a cheaper version like a Carrier makes a Bryant and Payne. You know, Carrier being the top of the line, Bryant being the middle, Payne being the low end. You know, we don't have that. All our components are the exact same. Now, some of the warranties may change, but that has something more to do with, you know, the type of equipment. So I'm not going to say that the warranty is going to be any different. It could be, but normally all the components are the exact same. The next will be the type of unit. This is a water-to-water unit, so it'll be designated with a W. The third digit is the staging. You guys are probably real used to seeing a T or an S for two-stage or single stage. Now we have a V for the variable speed. Then we have the unit capacity, again, either 040 or 060. The next is a revision. That's more if we were to change the brand of brace plate that we put in the unit, or we were to upgrade the compressor to the newer variable speed. We would change the revision because something major inside that system has been changed. Normally, when we change a revision, we have to take it back through AHRI for testing. So we try not to change revisions just on a whim. It's got to be a major component, and we'll change that. You don't really have to worry about the revision so much. It's very nice for tech support because something in the IOM could change with that revision. So that'll help us pull up the right IOM when we're looking at, you know, heat of extraction or something like that. The next is your voltage code, which one voltage code is all we offer right now, and that's 208, 230 volt single phase. That's it. The next is your hot water configuration. You can order it without domestic hot water. That's fine. Then you won't have a tank. But if you have the hot water configuration, you'll have it number 9. And then it'll reference over to the option number 11, which is your tank options. And I need to change that on here. You'll see it says 48 and 72 gallon, and that's not correct. It's 45 and 65 gallon on that number 11. So once you choose your tank option of 9 on option 9, then you're going to have to choose something for your tank option. It'll have to be 1 or 2 and not 0. The number 10 option is your flow center option. So we have pressurized and non-pressurized again, and 1 or 2 pump. So you have to choose that. Now, if you have multiple units and you're going to use a larger pump and you're going to source that somewhere else, or you're going to work with us on that, just choose an E for that application. The number 12 and number 13 are your heat exchanger options, which there are no other options besides braze plate. So those will both be B. And then the final 2 are standard stock. If we were to add something to the unit as an option, we would change that there. Some people might see an RS at the end of some of our equipment, which is a factory installed soft start. But SS would just be standard stock. We'll go over the serial number real quick. This is a quick example up top here of a Enertech serial number. All units that are built in Mitchell, South Dakota will start with an M. That's what that M means, Mitchell, South Dakota. The next 2 digits are your year, and the next 2 digits are your month, and the last 4 are a sequential number that's reset each month. It has something to do with the day and the number of unit that was built, but you don't really need to worry about that. Just know that it has an M, it's built in Mitchell. The first 2 are the year, the second 2 are the month. So this one would be built in September of 2017. All of our units are built in Mitchell, South Dakota at this time. The only thing that's not built in Mitchell, South Dakota right now is the air handler. And I've been saying this for years, about since I first started, that we're going to have our own air handler come out soon. Well, I promise you we will have it come out soon, maybe within the next 6 months or so, we're hoping. And then it'll have the microchannel air coil in it, and we can do that hydronically or with refrigerant, with a DX coil. So hopefully that'll be coming real soon. Again, I've been saying that for kind of a while, but I know that we're getting pretty close on that. So it seemed like it kept getting pushed to the back burner on the air handlers. Unit location. Make sure we're not we don't like them located in unconditioned spaces. You can have excessive heat, humidity, frozen water lines, things like that. So we'd like it to be stored in a conditioned space. Serviceability is always priority number 1. If you ask an installer, that's not the priority, but at some point in the life of this equipment, I mean, it will have to be worked on. I mean, that's just the way equipment is. So you're going to have to be able to get around the unit and get the doors open and work on the unit. The best would be, distance around the entire unit. That's not feasible in a lot of situations. So you have to get to the front of the unit. We got water lines coming out the back of the unit, and we need at least one side to access the refrigerant components. So you're going to need a pretty a good area there, 2-foot distance around the unit, so you can work on it. An insulated and isolated location is strongly recommended. The unit is not loud. It is loud. We've got the door off of it. Sounds like a regional jet getting ready to take off. But with the door on, it's real quiet. So they really shouldn't hear it. And you don't have any refrigerant lines that could cause any vibration. You could have some water lines that might cause vibration, but I wouldn't set it right next to a bedroom wall. They may hear it when they sleep. I can't give you decibel ratings on it because we don't have them. We weren't required to do that, and so we didn't. Going forward, some of our equipment will start to be decibel tested, but this is not decibel tested. There's also an audible alarm that could annoy some people if it locks out. So I just wouldn't, if I could help it, I wouldn't put it near a bedroom wall or floor. Dimensions, again, like I said earlier, the 040 and the 060 are the same size, and they're about 37 inches tall and 25 inches wide and 25 inches deep. Make sure you're setting it on a pad. We say air foam pad here. We've got a newer pad that's a rubber pad. It's about 1 inch thick, and that's what I would recommend. We've got 2 braze plates and a compressor, and we got 2 braze plates on one side and the compressor in the middle. What I've seen with the air and foam pads is that over time, they kind of start to sink a little bit, and it causes that unit to get out of level, and it's just not a good look. So I would recommend getting that 1 inch rubber pad and using it. Don't set the unit on corner shims or corner blocks. We've got to support the whole base of that unit. If we don't, what will happen is that metal in the bottom of the unit will start to weaken, and then the whole bottom could fall out of the unit. So no shims of any kind. There is a filter that's protecting the controls. There's a fan inside the unit, a case inlet fan that'll keep the controls cool. And there's a little piece of filter material in there that'll have to be changed annually, or when it gets dirty. Depending on where it's at, it could get dirty more or less, but it's basically, it needs 4 inches of clearance. There's a filter guard with a couple 1/4 inch turn fasteners and filter media right in the middle of it. Now, we do have a part number. It's RF119. You can buy it from us. But to be honest, I'm sure you have filter material on your trucks. And so you can just cut a piece of that and put it in there. It's nothing fancy. But it's just there to collect the dirt and debris so we can keep our controls clean and cool. This is the back of the unit. So the water lines come out the back of the unit, so we can't slide this up against the wall. We've got to have a little bit of clearance. Now, these are all double O-ring fittings, so you've got to use the double O-ring fitting. It's going to be double O-ring by hose barb because you're going to have rubber hoses coming off there. So you got the hot water out on the top, and then it kind of goes down from there, load out. You've got a common load in for your home and for your domestic hot water, and then your source out and your source in. On the source in, you're going to have a braze plate, or excuse me, a strainer on there. So make sure that you pipe that in. The strainers come with the unit. Whenever we have a braze plate, we have to protect them with a Y strainer, and that's recommended, or not recommended, that's a requirement from the braze plate manufacturers. So we'll use a strainer here as well. This is the top of the unit looking down, the red oval here, round disc, that would be your load pump. This is the insulated block here. This orange square, that's your 3-way valve for shifting from hydraulic heating to your domestic hot water. And then down here in the middle bottom, that's your case inlet fan. So all general Enertech and geothermal heat pump installation practices, procedures, and recommendations all apply to this unit. So what I mean by that is you still have to flush and fill the loop field. You still have to flush and fill the load side hydronic system. There's still the same type of electrical wiring. You know, there's breakers from the panel. You're still gonna have to set and pipe the unit and insulate both the source and load piping. And again, we still have that rule that the hose kit to the flow center is a 10-foot max one way, or max total length. So 5 foot one way, 5 foot the other. So 5 foot there, 5 foot back. So all the general installations still apply to this unit. You know, it's variable speed, but it doesn't change the fact that it's a geothermal unit. So we still have to, you know, flush it, put antifreeze in the system, and all that kind of good thing. Control strategies. There's a couple different ways you can do it. The way that we would recommend is basically on demand, which is the heat pump only operates if one of the zones or the hot water tank is calling. You know, with the TurboMax tank and the variable speed, we don't have a buffer tank. So there's no real need to heat up a tank and leave it when the unit can handle, as long as we've got flow, that we can run the unit only when a zone is calling. So we're not storing water. We're just producing the hot water when we need it. So basically, there's no buffer tank required, again, but we've got to have proper water flow. The load and the source need to see 5 GPM to operate. Now, I'm going to tell you, it's actually about 4.5, but we're going to set up our flow for about 5 to give it a tiny bit of wiggle room and a little bit of, you know, just a little bit of buffer there. You can also use it with a buffer tank. A dump zone, primary, secondary loop, a hydraulic separator. We will cover a little bit of the buffer tank hydraulic separator application because we're starting to go that route. But we've just found over time, air is a big problem when you guys are piping these things in, and that's our biggest issue is flow. And so we found that if we have air handlers that are smaller than 2 tons, we have issues with water flow rates. And so we would recommend a buffer tank in that application. Anytime we're using a air handler that's larger than 2 tons, we would recommend using the hydraulic separator. Now, we'll get into some piping here in just a few minutes, and you'll be able to see that. That's also in the IOM, so always, if you've got questions, refer to the IOM. If you can't find the answers to your questions in the IOM, definitely give me a call or call tech support with those questions. Now, if you call in tech support, I would probably recommend that you either talk to me, which again, my name is John, or I'm kind of pushing the primary responsibilities on the variable speed off to Kip Westrom. So you can ask for him as well. So I travel quite a bit, so I could be gone. I'll always assist you if I'm available, but Kip is very good with this as well. So we're the two kind of point men. Not saying that other people in tech support can't help you, but Kip and I have worked on this for a couple of years at least. I've been working on it a little bit longer than that, but Kip's been with us for about a year and a half, so he's been working on it that long. So in tech support, with so many guys, we kind of all get our own specialties, I guess you could say, and what we do, what we're better with. So Jeff is real good about finding our strengths and our weaknesses and kind of focusing our time on our strengths and working that way. So works out well. We've got a really great technical support team. I'm not going to lie about that. In my opinion, we've got the best technical support team. I could preach on us all day long. I'm sure it's not something you really care to hear, but I know that we do have the best tech support in the industry. So just my little rant about tech support. So this is the WV unit, obviously, with the source water connections. We've got on the left side here is a pressurized flow center, and on the right is a non-pressurized flow center. So here we've got our source in. Again, make sure you're installing the strainer. Now, just because the WV unit will tell you your water flow, I would still recommend that we install pressure temperature ports. That way we can confirm if those sensors and thermistors are reading properly, because those could always be the problem. So make sure you're always installing pressure temperature ports. On the non-pressurized flow center, we're not going to flush through the flow center. So you will need to add a field installed flush block, insulated flush block. You can make your own, you can purchase one from us. Doesn't really matter to me. Just make sure that you're installing your strainer in your source end water line as well. But that's a requirement. They come with the unit. So when we send them with the unit, it's not just a, hey, I'm not going to use it. It's, hey, you have to use it. This is a typical load piping. And here we're using a hydraulic separator is incorporated into the design here. This is a hydraulic separator here. The hydraulic separator is actually just like a buffer tank. Basically, it's a lot smaller. We're not storing anything, but like a buffer tank, it decouples the zone piping from the unit piping. So it decouples the flow. So if the WV unit needs 15 GPM and you've got a small air handler and it needs 3 GPM, you know, if the air handler was calling, we had 3 GPM and we did not have the hydraulic separator, the unit's not going to get enough flow. We have a bypass valve that'll allow the extra flow to go through. but it causes the unit to short cycle and things like that. So the better setup is to install a hydraulic separator, and then the unit will flow through the hydraulic separator and go back through and get its 15 GPM. Now the zone will pull through the hydraulic separator and just pull the flow that it needs to the air handler. So we decouple the two right here at this hydraulic separator. There is a little blowdown because it will act as a dirt separator as well, and also an air separator. So there's an air vent. Now, one thing you need to keep in mind when you put in the hydraulic separator is that you will have to add a field installed flush blocks to your zoning, as well as an external pump, so that when the zones call, it'll turn this pump on and flow to your zones. And then we have a boiler trim kit, if you're adding makeup water, that kind of thing, right through here. Expansion tank, PRV, check valves, things like that. So this is basically the setup with a hydraulic separator incorporated into the design. This is a buffer tank setup. You're probably a little bit more familiar with the buffer tank setup. But again, it decouples for flow. So if you have an air handler that's smaller than 2 tons, we'd recommend that you use a 40-gallon buffer tank. Again, it decouples the pumping for your zones with the WV requirements. Now you'll see here we've got 2 tanks. We've got your TurboMax water heater and an optional recommended electric or gas water heater. Now, we do this for if you have large consumption, so you've got a garden tub you're trying to fill up, or you've got 10 shower heads in a shower, you need more water, more hot water at one time. We would add a second water heater into the mix. This would also be for backup. Let's say your load pump fails in the WV unit, and you've got to order it. It takes a week to get it. Well, if that load pump is out, we cannot pump water to this water heater to heat it up. So now they're not going to have hot water for a week until they can get that pump. If they've got a backup or backup water heater, now they can still have hot water in their home. So excuse me. So as you can see, this is something that's come along after we've seen, it's been in the field and something has happened. They didn't have hot water. It's something that we've seen, and so it's what we're recommending. It's not required, but it's what we're recommending. And this would be how it's piped in. So again, these piping diagrams are in the IOM, and I definitely recommend you check those out. We do recommend the home run style piping. Basically what that means is all your valves and your header are in the mechanical room. It makes it easier for flushing. You can go to the valve and open it or close it without climbing into the attic or going down the crawl space or going to wherever that zone is at and opening that valve. And also, for troubleshooting, a lot of these valves have lights on them, so you can tell when they're open and when they're closed. And it makes it a lot easier, again, just for flushing. The branch style, it's not as easy to flush, and all your valves and things are not located in the mechanical room. So this is why we do recommend the home run style piping. Again, some of the components, we kind of already went through this. This is the variable speed pump that we're going to be using going forward. It may not be the one that's in your unit when you get it, but this is the one that's going forward. And it's a UPM XL. It's a 25-124 pump. It is more efficient than the Grundfos UPM or the UP 32-140. it'll do a little bit less pumping, but you probably won't even notice it. It seems to be a good replacement for us. Again, it does use less power. I know this picture is kind of fuzzy, but this is where the electrical box needs to be on the side. I'll go back here. So the electrical box here with your pump needs to go on the right side or the left side, never on the bottom, never on the top. This is the flow center pump comparison. Now we've got the Magna Geo here in the blue line. That's the older variable speed pump. And the reason we don't have that anymore is because they don't make it anymore. So it's not because we wanted to get rid of it. It was a good pump. They just don't make it. So the green line indicates the newer pump, the 25124. And so normally we're going to be within the 10 to 15 GPM range. So it can handle, 11, 12 GPM, a little under 40 feet, or just a little bit under 40 feet ahead. And at 15, we're running about 35 feet ahead. So you should be good with this pump. If you've got to replace for some reason, you've already got a 32140, the 25124 should work for you just fine. Some of the power consumption based on a 4 and 6 ton heat pump, and you can see it's quite considerable. The 124 as compared even to the Magna Geo or the 2699 2 pump. So about the same as the 2699 single pump. This is the internal 3-way valve. This is what shifts from domestic heating or hydronic heating, to domestic hot water heating. Again, it's just a 3-way valve. And you can move it by hand if you need to. If for some reason it were to stick, you could move it by hand. And you can also just replace the head on it, not the whole valve body. This is the zone valves that we recommend here at Enertech. We use these quite a bit on open loops and on zoning systems. It's a Tecos Geo Century valve. It's got a low CV rating. They're very reliable. It has an end switch that that'll have a little light indicator to let you know when the valve is open. You can remove this head. You got to pull on this little metal tab, and it'll come right off. You can also manually open these valves and leave them open for flushing and that kind of thing. Again, super reliable, a lot better than the orange-headed Tecos zone valves that we used to use back in the day. We've been using these for a long time now. So this is what I would recommend on your zoning, is the Century valve. These are your radiant manifolds. This is an in-floor manifold here. Now we sell these in 2, 3, 4, 5, etc. circuits, and they're usually a 1-inch copper running to it. You don't have to use in-floor manifolds. You can use whatever brand you'd like. This is just what we sell, so do what you please, but these are just some of the recommendations. We do recommend that the main piping on your load before the first zone is coming in at about 1.25 to 1.5 inches. And then you can, after your first zone, you can cut that down to 1-inch copper zone piping, but that's totally up to you. Air handlers, right now we're using the Mortex MPH air handler here to the right. It's got 3/4 inch connections stubbed out, but we would recommend running at least 1 inch, if not 1.25 inches, to the unit itself. Definitely use that zone valve as part of the application. We recommend that all air handlers are at least 2 tons and no larger than 5 tons. With the buffer tank, you could go into the smaller tonnages. But if you don't want to use a buffer tank, then make sure you're above 2 tons. If you need to know the exact specs for this air handler, now this air handler is built for geothermal units with the lower water temperatures. So you can check out the spec manual and find your capacities in there for the lower water temperatures. Again, we discussed this hot water tank earlier. You've got a copper coil that runs through, and the domestic hot water enters the tank on the bottom, slowly picks up heat as it rises through the bulk load water, and then goes out to your home. The WV unit, it pumps the hottest water into the top, and it circulates through the bottom and comes out the bottom and returns to the unit. That's that reverse return. When our water temperatures are closer together, we transfer heat better. So in this reverse return, the hottest water from the WV unit will be in contact from the hottest water in the domestic hot water circuit. Sorry, hang on a second. Again, it's a 45 and a 65 gallon tank. And again, loaded in the top, out the bottom, domestic hot water in the bottom, out the top. Again, just remember that this comparison is in the IOM, so we can get the right size tank for you. If you got any questions on that when you're sizing it, just give us a shout. Just some sizes of the tank. It is a little bit taller. 65 gallon tank's about 6'7", and the 45 is just a little bit under a foot or 5 foot. So they're about 250 pounds roughly. The domestic hot water connection is 1.25 inches sweat. The heat pump connection, 1.25 inches pipe thread on the 45 gallon and 1.5 inches on the 65 gallon. There is a pressure relief. It will open at 30 PSI. Go ahead and plumb that to a drain before you flush. As you flush, you might get pressure higher than 30 or whatever the pressure relief valve is. I believe it's at 30. But you could get above that pressure and then it'll spit some water out. So if you pipe it to a drain, it'll just go down to the drain and not that big of a deal. So just keep that in mind. Again, the source side water connections, they're all double O-ring fittings on the unit and on the flow centers. So you've got to have a double O-ring connection or connectors on it. That's going to come with the unit, so there's no reason for you to use anything else. If you've got an open loop, so you're doing like a pump and dump, you've got to use an external heat exchanger to isolate it from the unit. We cannot use open loop water on our braze plates. If you use open loop water on our braze plates, it will void the warranty on the unit. No open loop water. Those passageways through the braze plates are too small, and it'll collect sand and debris, and it'll plug it up and freeze it, and then you'll bust it, and then the whole unit's trash. So no open loop. We kind of covered this already, the piping. Just remember, always install your strainers. When you're flushing, this is a flush cart over here to the right. We have a newer flush cart now. It's got a sight glass on it, so you can see the level in the tank. But I would always recommend that you use these filter socks when you're flushing. They'll go right over this return line that hangs down into the tank. This one on the right, this filter sock on the right has been used. You can see it's got a bunch of rust and discoloration. This is a 100 micron bag here, and this is the 1 micron bag on the left, the white one. So we sell these bags. They're washable, reusable. I would definitely use these. They'll collect any kind of debris that got into the piping when the piping was installed. It's better to start out good quality clean water than it is to go back in there and try to clean it out after you've made a mess of things. So always filter, always flush. Source side flushing, it's pretty easy. Obviously on a pressurized system, you're gonna shut off your flush ports to the unit and you're gonna flush out through the loop field. On a non-pressurized system, it's got PVC in it and we do not want to flush through it. So you're gonna have, there is a little spot on the side of the non-pressurized flow center here that you can put a double O-ring fitting, but you will have to have a second flush block. And then we'll close off here and here, so we're not flushing, here and here, I'm sorry. So we don't flush through this non-pressurized flow center or through the unit at that point. We're just going to flush the loop field. Never flush through a non-pressurized flow center. We do require more than city water pressure for proper load side and source side flushing. So the load pump will not do it. You can try it, but it won't work, I can tell you that. Basically, I would recommend isolating the heat pump before flushing on a non-pressurized system, and don't flush through the heat pump. Whenever you do flush through the heat pump on a pressurized side of things, make sure that you're going with the direction of flow of the Y strainer. It's there to protect the braze plate. So if we were to go in the opposite direction, that first flush would force stuff into the braze plate. So make sure we're always going in the direction of flow through the heat pump. I would always test the water quality before you put it into the system. We have test kits at Enertech you can purchase, or you can send your water sample into me and I will test it for you and let you know. We do sell the kits from Fernox. I think they'll do like 150 tests or 100 tests or something like that. And they're just little test strips, kind of like a pool. And you can just dip it into the water and check it. So I would always check the water before you throw it into the system. And if it needs to be treated, all of the water needs to have inhibitors in it. So we have Alpha 11, which is a Fernox propylene glycol that you can purchase that's already got those inhibitors in it. If you're using some other type of antifreeze, make sure it has inhibitors. If it does not, we do offer a Fernox product that you can put in there that will give you the inhibitors. The inhibitors help protect the piping and the equipment from breakdown over time. So water quality, it seems like it's gotten a lot worse over the last couple of years. It's definitely not getting any better. So we're definitely working more on water quality at this time. You'll hear us talk about it a lot more. And we work with Fernox. They make a really good product. It's worked really well for us. So if you want more information on that Fernox, we have some water quality trainings, or you can reach out to us and we'll send you some product information. Again, isolate or plug the relief. Now don't leave the relief plugged, but if you need to plug it while you're flushing, that's okay. Just remember to remove it, or else it will purge water. If it's going to a drain, not a big deal. It's going to purge a little bit of water, not a big deal. It could suck a little bit of air in when you do that though, so just be careful. The last step when you're flushing is you're going to have to send power to the unit, and we're going to have to go into the startup wizard, because we're going to have to energize that three-way valve and switch it so that we can flush the hot water circuit. We're going to start when we flush. We're going to start by flushing the domestic hot water circuit in the TurboMax tank. So make sure to flush in the normal direction of flow here, because we've got a strainer on the load end as well, because we've got a braze plate there. So we're going to flush in through there. We'll flush through the tank and then back to the unit, or back to your flush cart and back through. That probably really won't take real long, depending on how far away your TurboMax tank is, but it won't be too far away. So it shouldn't take too long. Make sure you close off your valves when you're done flushing that tank. We're going to switch the three-way valve on the flush block so we can flush between the flush block and the tank here. You've got a little small circuit here that we're going to want to flush through. That won't take but a couple seconds there. Now, I don't expect you to remember all this, so I'm not going to spend a whole lot of time on it. These pictures are all in the IOM. So you can definitely go through the IOM. Again, I'm pretty sure you're not going to remember everything I say today. So when in doubt, check the IOM. Next, we're going to, here we've got a hydraulic separator in the circuit. So we've got maybe a air handler that's larger than 2 tons. So now we're going to flush through the unit, through the load out, through your hydraulic separator and back to your flush cart. So through the unit, through your hydraulic separator, and back to the flush cart. Next, we're going to flush on the other side of our hydraulic separator and your flush blocks. So this shouldn't take real long either, but from your flush cart out to the flush block, and we're going to be in reverse flow on this here and back. Now, if you got this hydraulic separator or your buffer tank installed, in order for the system or your zone pump, not the deadhead, we will have a second bypass valve here. So the next step is we're going to flush that bypass valve circuit. So we're going to flush out through the bypass and back through. It shouldn't take real long. Again, that bypass valve is there to protect deadhead on this system pump if none of your valves open up. The next is we're going to flush between your farthest zone away. So close off any other zones that are closer, and we'll flush or close off your bypass little circuit here, and we'll flush through your zone. And obviously just flush through till all the air's out. Then you're going to want to close these off, and you're going to want to flush your next closest zone, and so on until all the zones are flushed. After all the zones are flushed, we want to open up all the valves and flush through the whole circuit in case there's any micro bubbles still left in it. This is the final position of all the valves. So after you've flushed, make sure all your valves are in the correct position, and we're ready to go because we're going to start up the equipment after we get all your valves open. So this is a nice little highlighted area to let you know which valves are open throughout the circuit. Load side antifreeze, we know we're going to need it on the source side. So anytime you're cooling, we're using the chilled water, we require antifreeze in the load side of the heat pump. If you don't put antifreeze in it, that water could freeze and it's going to burst that braze plate. So if you have any heating zones that could potentially freeze, in a garage, let's say, you're doing radiant in the garage, or you're doing some floor melt or your ice melt, then you're going to have antifreeze in those locations. So either isolate those zones and install antifreeze there, or just put antifreeze in the entire load system. Load and source or braze plate, they don't handle freezing very well. If you freeze it once, you might get lucky. You freeze it twice, I guarantee you won't. It'll bulge, it'll separate, it'll allow the water to enter the refrigerant circuit. Then the compressor comes on, it pumps that water through the refrigerant circuit. and everything is junk at that point. You're never going to get all that water out, and you'll go through compressors for the rest of its life. It'll eat away at the windings of that compressor. So we got to keep the water out of that refrigerant circuit. If you get water in the refrigerant circuit on any unit, it's time to replace that unit. I don't care if it's 2 days old or 200 years old, it's going to have to be replaced. Electrical connections, we have low voltage connections on the right and the left, so whichever works best for you. The high voltage are in the lower half, and the low voltage is in the upper corner there. This is the control box. So we've got our digital controller, we've got our iPro controllers. This is the removable terminal strip for the calls to the unit. We've got pump blocks. We've got, if you have a fixed speed pump because you need more pumping, we do have a pump block for that. And we also have a pump block for the variable speed pump. They're labeled in the unit, not like this, but they'll have stickers that'll let you know which one is your fixed speed pump block and which is your variable speed pump block. We've got a pump block for your electric immersion heaters and for the compressor as well. So this one here is for your electric immersion heaters, and this is for the compressor itself. These are your immersion heater relays, so it's staged, and it'll turn these on based on the parameters set up on your controller. We would recommend a surge protector on the unit. Remember that this is a 208, 230 volt single phase unit, and it will have two different circuits, one for your geo and one for your backup electric heat. High voltage connection, you got your main power. Actually, I think it's flip-flop. This might be your electric immersion, and this might be your main power. I can't really be honest remember, but there will be a sticker that'll tell you. So it's not really, you don't have to remember either. This is your variable speed flow center. This is a pressurized here to the right. But basically the internal pump block, it provides power for a 1 or 2 pump flow center. So the variable speed flow center will have high voltage all the time, and then your internal flow meters and thermistors will tell the unit, you know, what the temperature and what the flow is, and then the controller will try to maintain a delta T of 5 degrees across your source in and your source out. This is the low voltage connection wire here. It's a little 4-pin Molex connector. The high voltage comes into this little box here. If you ever want to know if a variable speed pump, not only on the WV, but anytime you're using a variable speed pump, if it's working properly, and whether it's a high voltage or a low voltage issue, if you unplug this low voltage harness, then this variable speed pump doesn't know what to do. It confuses it. So that pump should run at 100%. It'll just ramp up. So if it doesn't come on, then we know it's more than likely not a low voltage issue. It's a high voltage issue, or a module issue, I should say. But I wish they would kind of do that on variable speed blower motors as well. If they fail, I wish you could unplug them and they go to 100%, because it's always the module that fails. You know, it's never the motor. I shouldn't say never. Very rarely is it the motor that actually fails on a pump or a ECM blower motor. It's always the module portion of it. So, but a real quick way to know if it's a control issue or a high voltage issue is just to unplug this connector, and it should run at 100%. Now, this connector that we have that runs from the indoor to this connection here is a 15-foot connector. That's a plug and play connector. We give you 15 feet, so in case you need to go up to the ceiling, over and back down, you've got plenty of cable. Again, pump locks, it's a fixed speed, so it has power when the unit tells it to have power. And this is the variable speed pump lock, so it will always have 230 volt to it. This is that 4-pin connector. Again, it's a plug and play wire, and there's 15 foot of it. It'll plug right in to the flow center and also to the board in the unit, pump relay board. This is the pump controller. This is the pump screen that you can go to. You can set your flows. You know, right now it'll tell you the status of the pumps, you know, the source and the load. The flow, if your flow switch is made, it'll say yes, and then it'll tell you the flow in GPM. It'll also tell you your entering and leaving water temperatures. This is your electric immersion heater again. It's built into the unit. It's a 2-stage. Requires an separate electrical circuit. You can control it either with auxiliary, or you can put it just emergency, depending on how you want to use it. The 2 stages are 4.5 kilowatt and 4.5 kilowatt. Again, this is your immersion heater power block. We talked a little bit about these field connections here. These are basically your thermostat calls, if you have it, to put it into regular terms, I guess. Basically, these are dry contacts. What dry contacts means is it just takes the contact closure. There's no power, there's no voltage between these. So Y1 and Y1C, you know, here on the terminal strip is how it's going to be labeled. If you were to take a jumper from Y1 and put it to Y2, there's no voltage to be measured here. Again, it's just contact closure. So if you put a jumper from Y1 to Y1C, you're going to have a radiant heat or a low temp heating call. If you were to jumper Y2 to Y2C, that'll give you a high heat air handler heating call. If you jumper O to OC, that's going to give you an air handler cooling call. You jumper HW to HWC, that's your domestic hot water call. R, we're not going to worry about. C, we're not going to worry about. And OAT and OAT, that's where you're going to mount your factory supplied outdoor air temperature sensor. So a real quick diagnostic tool, if the unit's not running and you think it should, disconnect this terminal strip. You don't have to unwire it, just pull it off, and jumper your Y1 and Y1C and let us know what it does. Does it run? If it does, then we know it's a control problem, not a unit problem. So it's a real quick way to know, do I need to look at the external controls, or do I need to look at the indoor unit? So again, you just take a piece of jumper wire and put it between Y1, Y1C, and the unit will run. Same thing with all of them. Just don't jumper R to any of these calls. It's not going to do anything, basically. So here, we'll take a quick break, 5 minutes. We'll come back at my time. It's 9:30 now. So 9:35, take a quick break, use the bathroom, grab a cup of coffee, whatever you need to do. Sorry guys, it took me a minute there. I let my dog out and she did not want to come back in. It's snowing and she likes the snow. So we'll go ahead and cover some of the HydroConnect controls, the controls for the unit that we would recommend. This is the HydroConnect zone panel, basically a blow up version of it. You can see we're using a Takeo zone controller with some factory installed relays here. We have to use these relays. This is a heating only Takeo zone panel. And so we would need to be able to do cooling as well with this panel. So we've had to add relays so we can shut off radiant zones when we're doing chilled water. We don't want chilled water going through our radiant zone. So in the future, once we get our connected controls, we can get rid of some of these relays. But for now, we've already got them factory wired for you. And this is a real plug and play. Now, as you can see on here, we've got 6 zones available here for use. If you need more than that, we do have an expansion that you can tie on and add 6 more zones. Now, on this zone control, one thing we need to remember is that this HydroConnect can handle 1 fan coil and 5 radiant zones. So if you have 2 fan coils in 1 radiant zone, you're going to have 2 of these panels so you can handle your air handlers. So just keep that in mind. That's one of the nuances of this equipment. Here's just a little bit more of a blown up view of that Takeo panel. So these are all your thermostats here, and these are all your zone valve outputs down at the bottom. Now in the IOM, there is a wiring diagram selection chart. Once you get to the diagrams, this will come up as one of the first things you'll see. So these are the different options we have available for the WV unit. So we have a heating only, heating and cooling with ducted zoning, heating and cooling using dual fuel, heating and cooling with fan coils only. Then we've got a couple different setups for that. And then heating and cooling with a buffer tank. And then it'll also reference piping diagrams here and here. It'll let you know what type of zone control it is. The HTC is the HydroConnect zone panel, and the ATEZ VCA, these are EWC. We also have notes on thermostats of which thermostats can and can't be used, and we'll cover that just a little bit further here. So basically a note on the zones is more than 6 zones requires another zone controller. That'll add 6 more. The AT series Emerson thermostats, they're going to be used for fan coils, and we recommend using the Infloor 29001 or the HBX THM 100 or 200 for radiant zones. The THMs and the 29001, those are all dual sensing. Anytime we have a zone that has forced air and radiant in one zone, we always want to use a dual sensing thermostat. What happens is if both of those are calling it, or if you get a forced air call when you have a radiant call, you're going to have a higher temperature leaving the unit than what the radiant floor may want. So if we have a dual sensing, when we got a floor sensor, if that water temperature gets too hot in that radiant floor zone, it'll shut off that radiant floor zone. Because a lot of times we need to limit the heat that's going to that floor. There could be sensitive hardwood floors or something like that. So anytime we've got radiant and forced air, we're going to want to use dual sensing thermostats. If you need additional zones, again, the expansion panel is required. Each expansion panel provides a fan coil and 5 radiant zones. When we look at that controller, zone 1, it will require a dual fuel heat pump thermostat. And we also recommend the dual sensing on radiant zones. We do have a setup if you're only doing air handlers. We're trying to get away from that a little bit, but would just be a bunch of relays. You wouldn't necessarily have to use the controls. If you've only got air handlers, just call us in tech support, and we'll discuss that with you, what may be your best setup. If you're going to use the MPH fan coils, we can use the EWC zone panel. And with the EWC, it's not going to require a master zone, and the system can switch back and forth from heating to cooling. On the EWC, it can handle up to 3 zones. One of those zones is there's 4 zones available on an EWC zone panel, but one of those zones is going to be a dummy. The EWC zone panel is made for air dampers, and so what happens when there's no call to any zone, all the dampers are wide open. Well, we don't want our water valves to be wide open when there's no call. So we use one of the zones on the EWC as a dummy zone, and we'll jumper R to G, and so that zone always has a fan call. And that way it'll power those water valves closed when they're not in use. If you're going to use any non-Enertech fan coils, you can use the EWC zone panel. And again, it doesn't require a master zone. You can switch back and forth. If you're going to use the multi-aqua or smaller air handlers under 2 tons, make sure you're putting in a buffer tank as well. I'm not gonna harp on these wiring diagrams all day long here, because I know you're not going to remember them, but I want you to see that they are in the manual, and you can compare the chart to the diagram number. That chart showed HTG1 is a heating only. So you can come to this page and say, yeah, I have a heating only and I have 5 radiant zones. I would like to mention on this that on these zone valves, if you have a 2-wire zone valve, you will have to jumper the 3 and 4 terminals. That 3 and 4, that's basically your ends. It's letting it know that that's open or closed. Well, this 2-wire valve doesn't have an end switch, so we must use the jumper. These 2 X terminals are used for enabling the system pump. So if you had a pump in between your zones and your hydraulic separator, that's where your system pump would be, is right here. And then as you can see on the top, you got your thermostat inputs, and then on the bottom, obviously your zone outputs. And then it's got some LED indicators as well, let you know what thermostats and valves are calling and open. This is the heating and cooling, 1 fan coil up to 5 radiant zones. Now on this, you can see you've got these little red lines. You will have to do a little bit of setup. If zone number 1 is going to be heating and cooling, we've got to make sure that this relay is switched over so that it knows that it's a heating and cooling zone. So make sure that we're definitely reading the wiring diagrams and looking at these notes and things so we can get it set up properly. And this is a ducted zoning on a fan coil, up to 5 radiant zones in one fan coil. All these gray areas in these wiring diagrams, that's field wiring. So anything here, this is all going to be field wiring here, and then up where your thermostats come in as well. This is a dual fuel backup. So we've got probably an A coil sitting on top of a gas furnace, a hydronic A coil, again, field wiring in the gray here. You've got your relays that you may need to have to adjust, just depending on the type of setup you have. This is a heating and cooling, a fan coil only, no radiant heat. So this is where you would use the relays, and you wouldn't have to necessarily use an EWC or a HydroConnect or HPX or any of those controls. A few notes is that the zone 1 thermostat, it's going to be set up in heat pump mode. And then any zones after that can be set up for conventional. This is using NPH fan coils with no radiant heat. This is the EWC zone panel. Some of you may be familiar with it from doing ducted zoning, but as you can see, we've got 4 zones here. Well, this 4th one up here, you can see we've just got a little jumper between R and G, and that's to give it that dummy call. If you need more than 3, then you're gonna have to get another expansion module for this EWC, which is available. Make sure we're always setting up the dip switches, and if you've got an expansion module, make sure it matches the settings that you have on your first EWC module there. Basically, thermostats on the left, on the right, and we've got our zone valves on the left, our WV input on the left, and then just some more settings up top. Same thing with no radiant when you're using multi-aqua or other types of fan coils. It's really very similar setup. You have to be careful on some of the air handlers. They may not be set up for heat pump. May be set up for a standard conventional system. So you may have to manipulate it a little bit, but we do list notes and things here for wiring those in. This is a heating and cooling up to 6 radiant floor or fan coil zones that you're going to require a buffer tank. So you've probably got some smaller zones. In this application, we're going to use the HPX Eco 550, which is going to be your buffer tank controller. And then there will be a couple of relays. Again, zone valves on the top here, and then your thermostats down on the lower portion of the plug and play terminal strip. Make sure that if you've got fan coils, that if they have transformers in them, that we remove them so we don't have phasing issues with the zone panel itself. This is a very confusing drawing here. A lot of this is already pre-wired for you from at the factory. And I wanted just to show you how confusing it can be, because if you had to do this all yourself, you'd be spending quite a bit of time. So that HydroConnect panel has proven to be really nice. It's easy for the guys to work on in the field. We haven't had as much problems as the HPX that we've had in the past. So this is the expansion panel over here for some more zoning and things. So we can add more zones if need be. This is a single buffer tank up to 6 zones with pumps or valves. So a lot of times we've got a system pump for our zones, and then we're using, we're using a system pump and then zone valves. You can also put zone pumps at each zone and do it that way, and this would be the setup here on that as well. This would be using HBX controls as well. So those are the controls. Another control that we have is an aquastat for your domestic hot water. And so basically it just provides the dry contact for that. You can set that. A lot of times I see them 120, 125, somewhere around there with about a 5-degree differential or so. Basically, when we set that aquastat, we're going to want to set it where the aquastat satisfies, but the leading load temperature does not exceed 135. These tank sensors or aquastats, I've seen them be off by quite a bit straight out of the box. So I don't really rely so much on what the temperature of the aquastat is, but I just want to make sure that we're not going above 135 leaving the unit when the tank satisfies. So basically you're going to monitor the tank gauge and the unit leading load temp on the HMI. And then you're going to tune the aquastat while it's running. So if the compressor shuts off and your tank is still calling, you've gone a little far with your set point. And we also recommend setting your temperature differential at a minimum, or your band gap. So we would recommend probably right around 5 degrees on that. Outdoor reset. So outdoor reset, that's why we send the outdoor temperature sensor. Obviously, the COP, or the efficiency of the heat pump, will go up as the load water design goes down. So the outdoor reset does make a lot of sense here. It's going to vary the design load temperature based on the outdoor temperature. So the colder the outdoor temperature, the warmer the load temperature. It's going to maximize the COP of the system. Again, we do include the outdoor thermistor. If for some reason you can't get that installed right away, or it's broken or something like that, we can do a static temperature set point if the sensor has failed. We can go into the settings and do that. Obviously, follow the manufacturer instructions for placement and mounting. We basically just want to position the sensor on the north side of the home and avoid sun exposure. We have heating curves. Once you go into your startup wizard, you'll get into some heating curves. We have 15 heating curves. And I don't know, I think it maybe comes from the factory at like 3 or 4 or 5. I'm not really positive, but I think it's 3. But you can choose depending on where you are in the country. You know, if we are on 3, when the outdoor temperature is 30, that water temperature is going to be about 79 degrees roughly. And then obviously as the temperature gets colder outside, we get into the 10 degree, then we're about, you know, 85 degrees and so on. So I know 3 usually works pretty well for here, maybe 4 or 5. You start getting up, the farther north you go, probably the higher curve you're going to probably need. Here's a little chart that shows basically the COP of a unit as compared to the temperature difference. So we're looking at source temperature versus load temperature. The closer those are together, the better our COP is. So the startup wizard, when you first power up the unit, it's going to send you through the startup wizard. You can always, there's a button on the HMI where you can always go back and redo the startup wizard. Let's say you don't have the domestic hot water hooked up right now. You could turn that section off, go ahead and run the WD for your heating needs or cooling, whatever you got. And then you can go back into the startup wizard once you're ready to complete the domestic hot water. You need to flush it, or you need to set it up. So you can always go back through the startup wizard as many times as you'd like. It'll force you through it the first time because there's important settings that we have to make before the unit will run. Basically, this is what's going to happen. You're going to go into the first run setup. It's going to keep the pumps and the compressor off until setup is complete, and it will guide you through flushing of the load and the domestic hot water. It will ensure minimum pump flow on the variable speed pump, and we'll review some of the critical settings such as outdoor reset. So we're going to have to flush each side. So when we get to this, where the diverting valve is in the house position, or the hydronic heating side of things. So if you press up or down arrows here, you can highlight that house. Once that house is highlighted, you can press enter, and it'll start to flash, and then you can change it to hot water, and it'll switch that valve over, and you can flush the hot water circuit. After you've done that, it's going to give you a warning that you must complete the flushing before we continue to the next step, because we're going to turn the pumps on and check our water flow. So if you haven't flushed, obviously that's going to affect your water flow if you got air in there. So make sure you've got it flushed, and then we can go ahead and move on. The first thing we're going to do is set the minimum speed for the variable speed source and load pumps. What we need to see is minimum flow of 5 GPM. And that'll set the parameter for the lowest that pump will ever run. Now, here we're showing 25 on the load and 25 on the source. Normally, that source pump is going to be somewhere between 45 and 60%. Just what I've seen from experience. The load, it's just really going to depend on your setup, but I've seen that a lot of times, somewhere between 25 and 40%. But just make sure we see 5 GPM, and that will be your minimum. So that percentage. So if that 25% is your 5 GPM, then that's where we need to set it. Always make sure your flow switch says yes, and you've got a minimum flow rate of 5 GPM on, on both the source and the load side. And you can just navigate through by pressing up or down on those arrows until, like, the load is highlighted in this picture. If you wanted to change this, you'd press enter, and then you could change that percentage. And then once you're done, you can press enter again, and then you can scroll back over to your source pump, press enter, and you can change it, and then press enter again to exit out of it. You'll next go to your heating set point. The heat max sets the upper limit of the load out water. So if you want the max that water ever leaves that unit at 90, you could put it at 90. And no matter what the heat curve tells you, the heat max will always supersede if it's higher or if it's a lower setting. The heat max is there for the floor protection. So if you've got expensive Brazilian hardwood floors or something, then you can set that temperature a lot lower temperature. Again, we covered the heating curves, not really going to cover that again. After your heating set point has been made, your setup is complete, and the unit will be ready to run as long as you've got your controls, your zones are calling, that kind of thing. So again, you can always go through the setup again if you need to later on down the line. I'm sure you're going to need to know the sequence of operation. It's pretty important when you're trying to troubleshoot things. And on the screen, it will tell you what state that it's in. So the first thing that's going to happen when it receives the call is it's going to say pump start. So the source and load pumps are going to run for about a minute, and you'll start to see some flow. It'll show you your percentages, things like that. Next, it's going to equalize, so the expansion valve is going to open and wait and make sure that the pressures are equalized. Next, the electronic expansion valve it's going to be about 40% open, and then the compressor is going to run about 1,650 RPMs or minimum speed for about a minute. After that, the compressor is going to modulate to reach target load-out temperature, and it'll give you a range when you look at the main screen based on your heat curve of what your RPM range is. And it may be 1,650 to 5,000 or 1,650 to 6,500. It just kind of depends, but it will try to give you a range, and it'll modulate to reach that temp. It'll probably ramp up pretty quickly on initial startup there. The EXV will then modulate to try to maintain 10 degrees of superheat, and the pumps will modulate to try to maintain 5 degrees delta T. It's going to try to always maintain that minimum speed setting. So if it's running at minimum pump speed of 25%, and that delta T puts it at 4 degrees, it's not going to slow the pump down anymore because it can't, because your lowest setting is 25. So it'll just put along there. When the call is done, the compressor will stop and it'll ramp down to 0, and then your pumps will ramp down about a minute afterwards. Then on the screen, it will say ASC, and there will be a 3-minute and a short cycle. Once that goes away, if the call has not come, it'll just say idle, so everything will be off. There is a total of 5 minutes on the Enertch short cycle, but you've got a pump ramp up for 1 minute and a pump ramp down for 1 minute, which adds to the 3 minutes. So it's 5 minute total. If your entering source water temperature is 30 degrees and the unit is running, the source pump will go to 100%. The compressor is controlled based off outdoor air temperature, and there's a target temperature, so the temperature curve or the manually set temperature. So it's going to monitor the load out temperature, and it's going to throttle the compressor using an algorithm to maintain the target temperature. So over time, the unit will learn more and more how quickly it needs to react and that kind of thing. It's kind of a little learning process. So it'll throttle the compressor to maintain the target. As the demand changes and more zones open or close, the compressor again will throttle to maintain that delta T across the heat exchanger. If you have a small load zone and you're not using a buffer tank or a hydraulic separator, it's possible to overheat or overcool because the compressor is running as fast as it can and it's trying to maintain its temperature difference. If that happens, the compressor will shut down, but the pumps are going to continue to circulate through that zone or the zones that are calling. Once the temperature is back either under or over the target and the 3-minute and a short cycle has expired, then the compressor will go ahead and start again. Now, we talked about the 5-degree temperature difference. We do have a little bit of wiggle room there of 3 degrees. So we can overshoot a little bit or undershoot, and we're still okay. It'll stop a little bit of the cycling, but if we do overshoot or undershoot, it will shut off the compressor until it's back within range. When we're switching from heating to cooling or hot water, the unit does not shut down. Basically, what happens is the compressor is going to ramp down to minimum speed. Now, if you're going into cooling, your reversing valve will be energized. If you're going into hot water, the 3-way valve will be energized. And then the compressor is going to ramp back up to proper speed based on your parameters. So unlike our combo unit or any of our other units, we don't lose that 5-minute time when we're switching modes. Makes it kind of nice. We can almost switch on the fly. little bit of the human-machine interface information. Again, this is the standard screen that you will see when you come up to the unit and push a button so the light comes on. Basically, it provides details about the system operation. There's buttons, they're kind of hard to see in this picture, but they're kind of shiny underneath it. But if you want to get to the compressor menu here, you press the button that's underneath it. And same thing with the pumps and the stats, system menu, and the alarm. So it's basically just going to show your information displayed regarding the mode, the status, the pump speeds, things like that. The main menu, if you press the main button, it's going to show you the current operating setting, and that could be either normal mode, test mode, manual, or emergency mode. The call is the current call from the external controls. So it's either going to be heating, cooling, or hot water. It's going to show your status. And that status could either be startup, equalize, run, shutdown, ASC, idle, or lockout. On the compressor, it's going to show this compressor here. It's going to have a little bit of animation, and you can see a little bar at the very bottom of it. Well, that bar will start running up and down this compressor and let you know that it's running. Underneath it, it will say the commanded speed and your range underneath it in RPMs. So it'll say 3750 RPM with a range of 1675 to 6200 or something like that. So it'll show some animation if the compressor is running. The pumps, obviously this is a load pump, source pump, they're at 100%. These little black boxes that are kind of around the volute will kind of spin. So there will be some animation here as well if the pumps are running. And then these are your electric heaters, first stage, second stage, and these will have black bars in them if they are calling. So first stage is calling, all four of these bars will be darker color. And if the second stage of the electric heat is on, then these black bars would be on as well. So if we press the button underneath the comp, that's your compressor menu. This is the screen that'll show up. The compressor speed feedback from the EV drive, so it's showing our range is 1650 to 5000. We're running at 1647 RPMs. You can kind of see the black on that pump or on the compressor itself. This will also show your temperature, and this will show animation as well if that fan is on. It will show your supply temperature and the calculated supply based off your algorithms and all that. The pumps menu, press the button underneath the pumps, and it'll tell you the commanded speed, whether your flow switch is open or closed. It'll say yes or no. The flow in GPM, and your entering and leaving water temperatures. Stats menu, in the stats menu, it's going to show you your superheat temp, your load and source BTUs, which may not be real accurate, your suction pressure, suction temperature, discharge pressure, discharge temperature. Now, we assume on the HE on our and HR on the source, don't really pay a whole lot of attention to the load. That's going to bounce around quite a bit based on the loads that are available, but or that are in use. But the source is the heat of extraction and heat of rejection, and they're using 15% methanol. So if you have a different type of antifreeze, your heat of extraction or rejection could be a little bit different. System menu, it'll tell you what mode that it's in, whether that's a normal, emergency, auxiliary, whatever that may be. The current call, so your heating call, The status of the unit, this one happens to be an anti-short cycle right now, or ASC. It'll show you the diverting valve position, the reversing valve position, your heater stages, outdoor air temperature, which I would imagine this one's not plugged in or something because it's 327 degrees. It'll show what your load coil temperature is and your source coil temperature. If you go into the menu, you have settings, you have indoor climate, hot water, pumps, and your system. So there's buttons across the bottom again, 1, 2, 3, 4, 5, 6, 7, and you can enter these different sub-menus here. Indoor climate, again, it will tell you whether we're in normal mode, standard mode, or economy mode. Standard's no electric auxiliary, normal's 20-minute delay, economy is 40-minute delay. You can set your priority setting, whether that's cooling or heating, and we're talking about hydronic heating, not domestic, obviously. You can set your electric heat delay in minutes. If these 20 and 40-minute don't work for you, you can set a different delay. Set your cooling set point. Minimum is 42, default is 45. You can set your heating max temp here and your heat curve as well on your indoor climate. Again, you can use these arrows to scroll through. Once it's highlighted, press the enter button and then use the arrows again to change it. Hot water mode, normal, auxiliary after 30 minutes, or no auxiliary. Priority, you can do heating or cooling, so that's hydronic, heating or cooling, or your domestic hot water. My take on it is I would rather have a hot shower than a warm floor. So I would choose hot water as my priority all the time, but that's totally up to you. Your hot water set point on your leaving, 130 is default, 135 is max. I see that the majority of the time about 125. And then we also have a hot water delay as well. We can change. It's not showing here on the screen, but we can change that. Pumps menu, you can go into this mode, into this menu here if you want to run your pumps, if you've had to reflush or replace a pump, or you want to set it up and run the pump to see what's going on. You can go in here and enable it to either intermittent or continuous, and auto or manual control mode. Auto is delta T. Manual is you're manually going to set it at a speed and let it run and see what happens. So it'll show you your minimum speed, maximum speed, and target delta T as well. The system, here you can go in here and test it. So you're going to normally obviously be in normal mode. You can turn it off if they're going to be gone or something and they don't want the unit running at all. You can turn it off. You can put it in test mode, which will speed up your anti-short cycle. You can put it in manual mode and control your compressors and pumps and things like that for diagnostics. You can also put it in emergency mode if the compressor were to fail. You can put it in emergency and then it'll run on electric heat only. Here you can change your units. So if you're in Canada and they're used to using Celsius, feel free to do that. You can change your pressure units. I don't know if I've ever used bar, but you're more than welcome to change that if you'd like. And then you can also enter the setup wizard again here. You can skip it. If you want to run it, you'll down here on the screen next to the menu button, just hold down that wizard button and it'll take you back to the setup wizard. The control, when you get into this control mode, it's used for manually testing. So here you can turn your compressor either off, set RPM at 1650, which is the lowest, or at 4500 RPM. Pump speed, you can change it accordingly, 5, 60, 100%. Diverting valve position, you can change it to house to hot water, your reversing valve position, and your electric immersion heaters. It'll kind of tell you what's going on with those, what position they're in, and things like that. Superheat menu, again, you can change these values. I do not recommend it. If you think that you need to change any of these before doing that, it's recommended that you call tech support. And we'll talk to the engineers and get their take on it. Again, HMI, the measurements are for reference only. So always verify with trusted tools such as temperature and pressure gauges, things like that. So make sure you're always double checking with your trusted tools. Faults and alarms. So if you have an alarm, in the right corner, you'll see this triangle. In the field, it looks a little bit more red. Here, it looks kind of orange, but that's going to be on. There'll be an audible alarm that's beeping, and then you may see a flashing right here on the screen of the alarm button, and your status will say lockout. So if you need to get to the alarm menu, press the alarm button right here that's underneath the alarm, and that will take you to this screen here. Now we have 3 separate menus. You can see down here at the bottom, iPro. If it's white like this, that's the iPro alarms menu here. If you need to go to the EV2, press the EV2 button. It'll take you to those faults and probe faults. The iPro, that's normally what you're going to see, like low pressure lockout, loss of flow, things like that. The EV2, that's going to be a variable speed drive fault and alarm, and the probe is going to be failed sensors. Now, you can see up here on the screen, there's 2 arrows back to back, and there's more than one screen for these alarms. So if you have, let's say you had an alarm, you hit the alarm button, you came to this screen. We're on iPro, it says low pressure. That is not the fault. Now we have CO1 highlighted here. So that's telling you CO1 is a low pressure fault, but it's not, you can see there's nothing listed next to the CO1. So it's not locked out. What we would need to do is scroll down over here and go to the next page and see if that fault is on the next page. You can see we have a fault here on this first screen now. So again, it's showing CO1, we've got a low pressure. That's not the fault. We need to scroll over to this C11 fault. We look at this bottom screen. Now that C11 tells us load loss of flow switch. So we have a flow switch and a flow meter, or a flow sensor, I should say. Normally, if we have a load loss of flow, we're going to have a load loss of flow switch and load loss of flow fault feedback. It may be C10 and C11, so both of these would be locked out. But again, just because you first put it on the screen and it's on CO1, that's not the fault. Go to where it says fault, and it'll tell you what that fault is. And again, there could be numerous pages. So make sure that you're checking the pages. You can also go to the fault history. If you go to the iPro button again, the one on the far left, and you press it again, it will list the alarm history. It will keep the 10 most recent faults, and it reports those back in how many minutes ago that happened in. So you can see that the alarm history here is load loss of flow feedback, and it happened 3 minutes, 7 minutes, 10 minutes, 12 minutes, and 14 minutes. And it'll hold the most 10 recent faults. These are all your faults and alarms. Again, I'm not really going to get into these. These are all listed in the manual, and I don't really anticipate you remembering them. But there's low pressure, high pressure. You can see we got high pressure switch, high pressure transducer, high entering and leaving source and load temperatures, discharge gas temperatures, source loss of flow switch, source of loss flow pump, load loss of flow switch, load loss of flow pump. These are all, the pump ones are feedback, and the switches are just that, it's a paddle switch in the circuit. But it'll tell you even if the system didn't equalize, low superheat, reversing valve failure, things like that. So again, it'll list all these different faults for you. There are lights on some of the boards. This is the electronic expansion valve controller here, the XEV. On this controller, you should have a TX and an RX light that would be flashing. They're normally orange. No lights would indicate no power or a bad module, and red would indicate a communication error. We also show an open and closed status over to the right of the valve itself, and it should be solid and blinking orange lights, and that would be pretty normal on there. This is the variable speed drive for the compressor here, and it does have status lights. Green flashing and green solid show normal operation. The red or yellow flashing indicates a problem that's based on pulse count. I do not know what those pulse counts mean, so if you do get that, just write it down and give me a call, and I'll get in touch with Jeff Croxall, our engineer, and see what he has to say about it. It's not very likely. I don't know that I've had one of these EV2 drives fail. Not that they can't, but I don't know that I've had one yet. So that's a good thing. Again, there's not a ton of maintenance on the unit. There is the case inlet filter that will need to be replaced. So again, there's a flat blade screw on the side. It's only a 1/4 inch turn. They don't thread all the way out. And you can, you can access that filter. We have a filter part number RF119, but again, you may just want to cut your own. It's probably cheaper and quicker. So in our IOM, we do list, this is an operating, safe operating range for the variable speed compressor. So we need to make sure that we're staying within this blue operating range of acceptable. Now we do have a little bit of safety factor, but we start getting out of this range, and this is when we have compressor failures. So we could get, lots of vibration, part failure, refrigerant leaks. So we want to make sure that we do not get too high a water temperature. You can see that at the max, we're going to be at is 135. So outdoor reset's going to make a lot of sense to help save the compressor and make sure we're always following along with this chart here. There's one for heating and there's one for cooling as well. That's listed in the IOM. Here's the cooling acceptable operating ranges. Recommended for all WV unit applications. Anytime you have a system with a fan coil that's 2 tons or larger, we recommend you install a hydraulic separator. If you have fan coils that are smaller than 2 tons, then we recommend a 40-gallon buffer tank. We recommend all piping be home run style to assist in purging of air and less pressure drop and easier to service. The system should include a boiler trim kit that includes an expansion tank, air separator, auto air vent, pressure reducing valve, and backflow preventer. The auto air vent should be located in the highest point of the piping. I'd recommend that your zone manifolds are in the horizontal position, not in the vertical position. They don't vent air very well in those manifolds if you put them in the vertical position. Antifreeze, so systems that provide chilled water for cooling must have antifreeze in it, in the load piping. Recommend the inhibitors as well. And that's a warranty requirement now, are those inhibitors or approved alternatives, the Fernox or some other brand, but for warranty purposes, those need to be installed. Heating only systems do not require antifreeze as long as there's no exposed piping, but you must include the inhibitor. And source piping will need antifreeze whenever you're operating in heating mode. So make sure it's got inhibitors in your source piping as well. Flush valves. Systems should include flush valves to facilitate the purging of the air. If you're going to install a buffer tank or a hydraulic separator, make sure that you're installing flush blocks on the secondary side of the buffer tank or hydraulic separator so that you can flush the load zones. The system pump, so the zone pumping, I would recommend a variable speed pump. You can use a fixed speed pump to provide pumping on the secondary side. You will also need a pressure differential bypass that you'll need to install to avoid deadheading that pump. Strainers are supplied and they must be installed on the inlet of the load and source water lines. So you can just make sure that you're always installing strainers on the source and the load. They're supplied with the unit. It's not an option. So I had a question about antifreeze. I don't really care what type of antifreeze you use, whatever you're comfortable with. You can use the same on the indoor that you do on the outdoor piping. It can be propylene, it can be methanol, it can be ethanol, whatever it is. Just make sure we're not putting too much antifreeze in or not enough, and that we have the proper inhibitors in it. Everybody has their own preference on antifreezes. Sometimes codes will come into effect as well. So whatever you use on the inside, I would use on the outside. The load piping, I would use on the source piping as well. In large usage applications, so a typical residential application, a second water heater is not necessary for capacity reasons. But in large usage applications, such as spa tubs, multiple shower heads, we do recommend a second water heater to meet the water needs. So you can basically, I showed you that picture earlier, you can install a gas or electric water heater to add that extra need that you need. It also adds redundancy to the system. So if the WV pump were to fail, or there's some other issue with the heat pump, and it won't allow the heat pump to run, we can still supply them hot water. So it's just a little safety fail-safe for them. So with that, that's what I have for today. If you have questions or comments, you can definitely ask them. You can email me. You can email, my email address is here, john.pendleton@enertechgo.com. You can call technical support, or you can email technical support as well. The email is nice if you have pictures or something you want us to look at. You can just send them to that email account, and that goes to the group as well. So, and you can always send it there and request me, put my name down. Hey, can you have John take a look at it? They'll forward that email over to me. So, but again, thanks for joining me today. I know it's a little bit longer webinar. I tried to shorten it up a little bit. In the future, if you've gone to the newest, seen any of the newest videos on the Advantage air to water unit that we're releasing, that's what I'm going to do with this WV in the future. So I'm going to start working on that in January and hopefully have that done by maybe mid-February or so. So we'll have shorter little 15-minute videos like we do in the Advantage unit. So definitely check it out. I do have webinars once a week on usually Wednesdays. So I do have a webinar next week. I don't know how well it'll be attended with Christmas right around the corner, but on our lockout boards and our other units. So definitely check out some of the webinars on our Enertech University website, and hope to see you guys again soon. Thanks so much for joining. This webinar is recorded and will be uploaded to YouTube later on today, and you should get a notification when it's uploaded, and you can go over there and watch it again or whatever you need to. So thanks again for joining, and have a great day and a Merry Christmas and Happy Holidays.